Ever pondered over how memory is managed in the world of programming? Well, it's like an intricate dance where each step is crucial for the flow of the sequence. Memory management, in essence, is the allocation and deallocation of memory blocks in a program. It's an important aspect of programming that can't be overlooked. Without proper memory management, we could face a plethora of problems. Think of memory leaks, where memory that is no longer needed isn't freed up. This could lead to a gradual slowdown of the system, and in the worst case, a system crash. Quite a nightmare, isn't it? Memory management is not just about preventing issues, but also about optimizing the use of system resources. It's about being a good citizen in the world of programming, making sure we're not hogging more than our fair share of memory. But fret not. There is a superhero in the programming world that helps us manage memory efficiently. It's called the garbage collector. So, what exactly is this garbage collector and how does it work? Well, let's imagine the garbage collector as a superhero in the world of programming, always on the lookout for clutter. This clutter is composed of objects no longer needed by your program. These objects, once useful, are now just hogging precious memory space. Our superhero, the garbage collector, swoops in to save the day. It identifies these memory-hogging objects, the villains of our tale, and promptly removes them from the scene. By doing so, it prevents a potential catastrophe known as a memory leak, where unused objects pile up, slowing down the program and eventually causing it to crash. The garbage collector operates either concurrently or in parallel with the rest of the program, ensuring minimal disruption to the code's execution. This way, it efficiently manages memory without causing unnecessary pauses in your program. Sounds like a dream, doesn't it? But how does the garbage collector know which objects are no longer needed? The secret sauce of the garbage collector lies in concepts like references, object lifecycle, and generations. Let's start with references. A reference is like a map guiding the garbage collector to locate objects. When an object has no references, it's like a treasure lost in the sea, ready to be collected. Next, we have the object lifecycle. Think of it as the life journey of an object, from birth to death. The garbage collector steps in when objects reach the end of their journey, ensuring they don't turn into zombies and haunt our code. Finally, we have generations. Generations categorize objects based on their age, with the theory being that older objects are less likely to perish. The garbage collector primarily targets the young, reducing the overhead of scanning the entire object heap. Now that we know how the garbage collector works, let's see how we can make it work more efficiently. The efficiency of our superhero, the garbage collector, can be influenced by how we design our program. Now you might wonder, how exactly does program design affect the garbage collector? Well, let's get into it. Consider the life cycle of an object in your code. If you create lots of short-lived objects, the garbage collector has to work overtime to clean up after them. On the flip side, if you create objects that live for the entire duration of your program, the garbage collector can take a breather. So, one design choice could be to reuse objects whenever possible. Another factor is the number of references to an object. An object that's heavily referenced takes longer to collect. Try to minimize unnecessary references, and you'll make the garbage collector's job a whole lot easier. Understanding these aspects can help you avoid memory management issues and write more efficient code. So, the next time you write a piece of code, remember our superhero, the garbage collector, and design your program to make its job easier.